Good day, everyone. So, today is the continuation of our practice of using different kinds of logical connectors. For this course or this tutorial lesson, we will learn about complementation and also XOR. So, let's begin. So, here, let's go first and run the demo. So, in order to do that, cd tao lang uh, demos. From here, um, okay, so we will use the demo 1.1. So that's run.sh, then demo underscore 1.1 dash basic syntax and history. That okay, so push down. We already done this one. Um, so we have already done this one in the previous tutorial lessons, and also disjunction and conjunction, also this one. And today we will talk about complementation and zeros and ones. Okay, so let's begin. Okay, so here let's type in, we will use the build release. So here is cd, then tau. Okay, so here let's run this one. Okay, okay, so complementation, let's study complementation. So here on the right side, I wrote down the formula. This is the original formula from the demo. And after this, running this one from here, okay, you can see I write it down, x plus y and z prime. And then after entering it, it becomes this one. So here, this is this one. Okay. So today we have the practice. So we can sharpen our skills in analyzing the logical expressions, uh, Boolean formulas. Okay, simple. So here, let's try to. So I added here this one, the the title, and then also the variables used, colon equals, and then the logical expression. So we can normalize it and run, and let's see later, as we have previously done in the previous tutorials. So here, instead of just writing this one, let's write complementation. So to have more space, so and also this one later we will discuss this one. So here, I also did this one here. So this is the XOR exclusive OR. I will talk about this later. So here, y plus 1 and then OR 0. And then this is the original formula. And then is after evaluated is y prime. How did it do that? So let's see. Okay. So start here first. And then let's exit this one first. So we have a bigger window. So Control B and then Q. Wait, let's finish this one. Okay. Okay, then exit. Okay, so now we have a bigger window. Okay, so here I'll write implementation and then the title of the name of the function, and then variables used x, y, and z. And then this one, x plus y and So actually, we don't need to write the end, but to clarify things, I'll just write it also. Anyway, so this is the function first. So enter. Okay. So now you see after tau evaluates the logical expression, it becomes like this. So it's just one x prime y or x y prime and z prime. Okay. So here let's write here the all the possible combinations, and then this is okay, and then and then okay, correct. 4, 4, 2, 2, and 1, 1, 1. Okay, so that's it. So let's see this one first. So here, um, as we have in the past tutorials, so when you say prime, it is the opposite. So this becomes the opposite of 0 is 1. So that's it. The opposite only. So 1. Okay. Now let's focus our attention to x plus y. So when we say x plus y, so this is, let me highlight this one first. Okay. So now this is a bit new, right? So when you see plus, it means it's x. It's me x. I sorry. When you see plus, it means okay. The symbol is exclusive or. When you say exclusive or, okay. So this means that, for example, you have x here and then y here, y here. X plus y means that is. So here this is x plus y. So this means so let's first populate 0 1 0 1. Okay. So here if in x or if you have both x and y have both value 0 0, you get 0. And if x and y are both 1 also, they are also 0. You only get you only get 1 as the result output if the two inputs are not the same. Okay, so that is the rule for the XOR. Okay, so I hope it's clear. So here it's so here let's focus 0 0. This is 0. Sorry. So this is 0. 0 0 0. 0 1. So opposite. They're opposite. They're opposite. 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 Then 0 0. Okay. So that's it. Okay. Now this one x plus y. Okay. We focus our attention now for x plus y and also z prime. So now here, we will end. Again, when you see end, let's delete this one. So I hope it's clear. So here it's end. Let's just recall the function end. So for end x and y, okay, we will only get 1 if both the inputs are 1. So here is 0, 0, 0, and 1. Okay. So here 0, 1 is 0, 0, 1 because both are 1. 0, 1, and 0, 0, and 0. Okay, so that's it. Okay, so let's see if they are matched with this one. So again, let's just copy this one so we don't have take a lot of time. So here's one, and then copy this one. Okay, now this one is just the opposite of this, so I'll just make a shortcut. and this here. And this one is the opposite of this. So here and 0. Okay. Now when we say that x prime y, so if there is nothing in the middle, again, it's an end. So here we focus our attention in x prime and on y. Here. Okay. So let's end this one. So 0, 0, 1, 1, 0, 0, 0, and 0. Okay, done. Now let's go for x and y prime. Okay, let's see. 0, 0, 0, 0, 1, 1, 0, and 0. Okay, done. Now let's OR these two because it's here, it's OR. So OR means, let's recall again, OR is x and then the pipe symbol and y. So here we will get 1 if either of the input is 1. So this, okay? So here is 0, 0, 1, 1, 1, 1, 0, and 0. Done. Now we will have this one, the result of this, and end with this one. Okay. So again, when end, both of the inputs should be 1 in order to get a result of 1. So here is 0, 0, 1, 0, 1, 0, 0, 0. Okay. Now we're done. Let's see if we are correct. So here is the combination should be on the third and on the fifth only. So here in the third and the fifth. Good. Okay, so let's test here. So in order to test, just recall this one and normalize. So instead of xyz, we will replace this with a okay, so here is first 0, 0, 0. So the output should be 0. Correct. 0, 0, 1, 0. Correct. Third is 0, 1, 0, 1. Correct. Next, 4 is 0, 1, 1. Should be 0. Correct. Here. Next is 1, 0, 0, 1, 0, 0 is 1. Correct. Here. Let's go to 1, 0, 1. Should be 0. Good. And 1, 1, 0 is 0. Correct. And last is 1, 1, 1, 0. Okay, good. So we see that both of them are showing the same results. Here and this one. Okay. Let's go to XOR. Okay. So here, let's write here exclusive or y plus 1 or 0. So same as this one. Okay, let's see. So here, let's write here 0 and 1. So here, this is 1, so I will put here 1, 1. And then here we remembered XOR. We will only have um, result of 1 if the two inputs are the opposite with each other. So here, if this one is, see, this is 1 and this is 0. And then here, um, so we didn't have the 0 here, so I will add the 0. Okay, so I will add the 0 here. Um, and then 0, 0. Okay. So here, let's focus our attention here and this one here. Okay, so OR, right? The OR means what? OR means we will have 1, result of 1 if either of the two inputs are 1. So here this is 1 and this is 0. Done. Okay. So here, this is 0 and this is 1. So we see here the opposite of 0 is 1 and the opposite was 1 is 0. So that's it. They have the same results. Okay, so let's try. So here, instead of y, let's try 0 first, and then let's normalize to see what is the answer. Should be 1, correct? And here is, if this is 1, 0, correct. Okay, so I have thought of a, let's say, a real life situation where we can use this formula. Okay, on real life situation, this is what I proposed. So this is two-layer safety mechanism. So let me tell you about this one first. So here's like um there's a pipe, okay, gas pipe here, and then there are two pressure sensor X and pressure sensor Y, and also the two pressure sensors should be on the same level. Okay, if um yeah, so in one pipe, okay, there are two pressure sensor lever here. Okay, so the pressure sensor X is in this place, and pressure sensor Y is on this location. Okay, so why did I choose the pressure sensors and then alarm? Okay, um, here we have seen, actually what I did is I reverse engineered this, and I just thought of a way to um, what is the real life scenario where we need to have a result of 1 with these combinations. So how did I arrive to that idea? So what I did is, actually I don't have this idea first, no? So I only have this um, results, and I saw in the results that there are only two possible ways to make this equation have a result of true, which is xyz should be 0 1 0 and also 1 0 0. Okay, so I haven't thought about this. Okay, so what I did is I reverse engineer, and maybe what with this formula, logical for expression, um where can I use um this logical formula, whereas the result will only be true if xyz are 0 1 0 and 1 1 0 0. Okay, so what I did is um here I saw that both of them are 0, and here both of them are 1 in this. So I remove this one. Let's see, let's analyze this. So here I will put maybe here and this one. And here. I noticed that in this area, right? So so I focused my attention here. Okay, I will put it maybe this one. Okay. So here, the only thing that we have to think of a way is this one. I mean these two. I'll make it bold. Okay. Okay. So what did I notice here? Okay. I noticed that um, if one of the variable xy is 1 and one is 0, if they are opposite, that's the time uh, there is a 1 here. So how about this? Okay. So here I saw that um, both of x and y are 0. Sorry, x is 0, y is 1. X is 1, 1 is 0. Okay. So, and here, what is the common between the two? Both of the z is 0. Okay. So we remove this one. Mm. So we focus our attention on this and this one to get the 0. Okay. So here, I thought of as um, two pressure sensor. Okay. So if both of them are low, it's fine. Here, both of them are low, so doesn't care. Both of them are high, doesn't care. Okay. It only cares if in this area where x and y are both high or low. Extremely high, one is extremely high or one is extremely low. So let me like just imagine, say, if this is 0, this is maybe extremely high. Sorry, extremely low, the pressure. If it's 1, maybe it's extremely high. Okay. So if both of them are extremely high, okay, both of them are extremely high, do nothing. Both of them are extremely low, do nothing. But here in this area, one is extremely high and one extremely low. Here one extremely low and one extremely high. And here it's one extremely high and one extremely low. Okay. So we got this one. Okay. But the problem here is this one. It's 4. Should only be 2 results, right? It should only 4. So we have to consider also the z, this one. Okay. So here, let me um okay, this one. So here, um I thought of a way that if z is 1, means to say um nothing, do nothing. Okay, if z is 1, do nothing. But if z is 0, do something. Z is 0, do something. Okay. So now we remove this one. Okay. So now let's focus our attention to this one. Okay. So Z is the alarm system. Okay. So if so this is for the pressure. I'm just making this up to just give you the some kind of glimpse of how it's like an abstract thinking. So here is this is the pressure sensor. I'm just imagining things. So here, just to teach, and this is the alarm. Okay, if the alarm is 0, it means there's no alarm, no signal, or there's no warning. If 1, so means to say it's active, it's there is warning, or there is signal to warning. This one is no signal. Okay. So here, um, if the alarm is 1, means to say it captured that. So let's look at it this way. Okay. The concept here is that in one pipe there would be two. There is two pressure sensor, and both of them should be the same level. Okay. If this if pressure sensor X is high pressure, X pressure sensor Y should also be high pressure because they are only in one pipe, right? It makes sense. Okay. If this is low pressure, if X pressure X sensor X is low pressure, pressure Y is also low pressure. If pressure X is high pressure, pressure Y is also should be high pressure. Okay. Now, if if pressure X is not the same as pressure Y, so this is extremely, in this case, on let's focus our attention on scenario 3. So in this case, X is 0 means to say the pressure is very low, and then here the pressure is very high. Okay. In this case, let's look at this one. Same. Pressure sensor X is low, very low, extremely low, and pressure sensor Y is extremely high. So, and then Z is the alarm. So if it means that it detected the extremely difference in the pressure sensor. So if it detects, so it means to say the second layer of safety mechanism will not function because the alarm, the first layer, the alarm on the first layer did its job, right? So if the alarm saw that there is a difference in X and Y, so it will turn on and it will alert the personnel, right? So in this case, layer 2 safety mechanism um, will not act. Okay, that's why it's 0. Also, this one here, 1 and 0. So X is extremely high, while Y is extremely extreme pressure sensor extremely low. So again, the alarm detect that, and that's 1. And if it's 1, means to say um, second layer safety mechanism will not kick in, will not do something. Okay, but if, okay, here, if both of them are different and the first alarm system Z, the first layer safety mechanism didn't make an alarm, okay, that's the time the second layer safety mechanism will kick in. Okay, same here. And condition scenario 5, again, both of them are have a extreme difference. Okay, and that should sound the alarm of the Z variable, right? But Z didn't do its job. It's 0. So in that case, the second layer will make an alarm. Okay. So yeah, I hope it's clear. So this means that in this scenario, this formula, logical formula, okay, can be used as a second layer safety mechanism. If the first layer safety mechanism didn't function well, okay, it will observe, okay, in a higher, like in a higher level, it will observe if this layer, if if the alarm system in the first layer is doing its job. If it's doing its job, see, it did its job, right? This one, it did its job. There's a difference of the two variables x and y is 0 and 1, and it did its job. It turned on. It's 1. Okay? And that in that case, it did its job. So the second layer will not do its job because the first layer already did its job, right? Okay? Same is here. Okay? X is extremely high and low and y is extremely low. So and the alarm on first layer safety mechanism did its job because it turned on 1. So again, second layer safety mechanism will not do anything anymore because it did its job. Okay. But here, on the third scenario, okay, there's a pressure difference. There's a very big difference, extremely high, extremely low, and the alarm system didn't do its job. When it didn't do its job, that's the time the second layer safety mechanism will perform its job as a second layer safety. Same as in scenario 5, there's a big difference there's a difference of x and y. Okay, there's a difference, and alarm system didn't function properly. We don't know why, but in any case, if that is in this combination 100, the second layer will kick in and will perform its job. Okay, so I hope this is clear. If you have any questions or clarifications, you can just ask me on Tao Telegram group or in forum or in this comment section down below. Thank you so much. Have a nice day. Bye.